This question, we have a meter stick set on a fulcrum. So we have our fulcrum here, and there's a meter stick, and that means that the meter stick is free to rotate depending on the torques. We know this is a positive omega, positive alpha, and the direction of positive torque. And we are told that there's a force of F at this location, and so we could determine right away what's the torque. The torque is RF, and so the R in this case is 2, and the force is F, so we have a torque of minus 2F. That's what the torque is, because if clockwise is the positive, then the other direction is the negative torque. So that's the torque we have from this. So I don't know what the question is yet. I'm just making sense of what's going on. We think of something that's free to rotate, and we have forces at a distance. We're thinking torque. Meter stick shown. At which of the labeled positions must an upward force of magnitude 2F be placed? So to put it in equilibrium. So let's just first determine, where does this force have to be? Upward. Where would you put an upward force? Well, if we put an upward force anywhere on this side, it would enhance it. It wouldn't be in equilibrium. So it can't be C or D. It can be neither of those, because upward forces in that direction would enhance the effect of F on the other side. So we're down to 50-50 just by knowing that. So we're now going to apply a larger force. We know this has a torque of minus 2F, and so what we need is a torque of positive 2F. So the torque that we would need is RF, and we need it to be positive 2F. And R, we don't know, but we're told the force must be 2F. 2F times R must equal positive 2F, so R must equal 1. If we apply 2F at this location, then we will bring it into equilibrium, and that location is B. And you could think about this if you are, if you have a door. Let's do an upward view of a door. So we're looking down at the top view, and if you look down, so we are in the sky looking down at this thing, and if you're going to apply a force at these different locations, A, B, C, and D, where is it the hardest to produce the same acceleration? Well, it's hardest when it's at A, so you need a bigger force at A, and that's like what we have here with B.